Okay, let's start working on the Chapter 6 exercises. I'm going to jump back over to our unit folder here and just get the exercise numbers. So we're going to work on exercise 1, 2, and 4 today. I think all of these are multi-parters and might take a little bit of time, which is why I only chose 3 exercises for this particular chapter. Let's begin by reading the description of what we need to do. And it says, write a program that initializes a list with 10 random integers and then prints 4 lines of output containing every element at an even index, every even element. Okay, see the difference between those, right? All elements in reverse order and only the first and last element. So we got to figure out how to do all those different tasks. And you know what? That's actually a little bit of work here. It does actually require, too, if you notice from the first instruction that it says random integers. We have to figure out how to randomize, and I'll show you how to do that. We're actually going to import a library that will help us do that and get started. So make sure you fire up whatever IDE you're using. I'm assuming most of you are using Spider like I am. I'm also going to do a little bit of file management on the front end here. So I'm going to bring up a file folder and create a new folder for this work. So I'm going to go to my Google Drive here where I'm doing my stuff, and we're working in this particular folder. I'm going to create a new folder for Chapter 6, and then everything is going to be saved in there. I'll leave that open just in case I might need it. All right, so let's go back and find Spider and get that started. And I'm going to bring those instructions back up again. And you know what? I think I'm going to do the trick where I'm copying them in to the actual document, because I think that will help. I'll just drop them right here at the top. And boy, that was not a pretty paste, but I can clean it up. No problemo. So there's our tasks for this assignment. Let's go ahead and do a save as on this right away. This is going to be exercise 6.1. I got to make sure it goes into the right folder as well. So x6.1 and save. Right. So the first thing that we have to do, and you guys can research this in your book, of course, or in the appendices, actually, is I think where you find this information. But we will need to do some random number generating. So we want to pull in a library, and the way that we do this is like this. So the command is from random import rand int. So this is something that will import the random number generator that will strictly generate integers. All right, so that's what we want to do. It says, write a program that initializes, okay, I don't need to switch back, 10 random integers and then prints 4 lines of output. So one thing that I find helpful when I do something like this is to kind of conceptualize a little bit how I'm going to do it. All right, so the first thing is we're in a chapter for lists, right? So we know we're going to be working with lists. So can we first build a list structure that we can put stuff into? I'm going to create one. I'm going to copy what the book did, and I'm just going to call it values. And I'm not putting anything in it right away. I'm just declaring it so that it's already there. All right? The other thing that I want to think about is how many integers am I going to be working with? And here's one of these things where as a programmer, you're going to be tempted to just basically hard code values in, and there's nothing wrong with that. But I'm going to show you my approach is to think about all the numbers that we use in the program in terms of like the limits of what we're doing in terms of variables or supposed constants. So I'm actually going to create like I guess a pseudo constant is what I call them in Python, because they're not really constants, is I'm going to create a thing called num integers, which stands for the number of integers I'm dealing with, which is how many? 10. because that's what they told us. So I'm just declaring this. And then one of the reasons for doing this is if you want to come in here and you want to change this program and make it a list of 100 numbers, all you have to do is change this one variable and the whole program is going to scale out. So every time I want to use the number 10, which is going to be used often, I'm going to use num integers instead. That's my thinking. All right, so I created this list, but now I want to start putting values in there. And what I'm going to do is I'm going to copy a technique that they had in the book for doing this, and I'm going to do it like this. I'm just going to copy in all the code in one fell swoop. All right, so I'm first going to set up a for loop, and in that for loop, we're going to run from I, which is going to start at 0, up to the number of integers. Now what that will do is it'll go from position 0 to 9, right? Because num integers is 10, right? And then I'm going to run the append function that you see on line 20, and to populate each position, I'm going to run the rand int, so the random integer is going to generate the value for us, and then it's going to stick it in to the structure for us following this little algorithm. So that little algorithm will fill the array with a random set of integers from position 0 through 9. That's what that will do. All right. So now that we have numbers in there, now it's our job to start displaying all the stuff that they're asking for. So we initialize the list with 10 random integers, did that, and then prints 4 lines of output containing the following. So let's work on the first thing. So the first thing that we're going to do, and you know what, it might be helpful to actually jot down what we're doing. So, and here I might say something like this. Generate the random integers. All right, that's what the first part did. Now we're going to display the elements at the even index numbers. All right, so here's what we're going to do. Let's first be a little preemptive and just put something in that kind of describes what we're doing. So we're going to say elements at even index positions. That's the text I'm putting in. Oops. And then what I'm going to do is I'm going to put in this end equals thing. You guys remember what that does? Keeps everything on the same line. So the next line that follows, my next print statement will print right after it. Because that's what we were asked to do, put it on 4 lines of output, so it's going to be all on one line. So let's get that going first. And then, you know, obviously the logical thing to do here is to set up a loop. So I'm going to say for I in range, starting at position 0 up to the num integers, and then step through it by 2s, right? We're going to start at 2 or at 0, and we'll go count up by 2 each time. So we'll go 0, 2, 4, etc. So it's just going to step through the list structure using every other index position. Then all we have to do is print it to the screen. So to do that, I just go to our list, and then whatever is in position I is what we're going to print. And since we want it all to stay on the same line, I'm also going to put that end command here so it stays on the same line. And actually, let's put a space in there so that it separates the values a little bit. 1 space, 2 spaces, whatever works for you. And then finally, when the loop ends, I'm going to do a separate print command just to print a blank line, to stop the line, you know, so we can go to the next line. So I'm going to do that with each one. All right, let's make sure that that works. You guys with me? Let's save this and just run it so far. All right. So we don't know what numbers it put in, but this is telling us what numbers it put in. What might be helpful, and maybe we should think about this, is maybe we should do a separate little loop that prints everything that's in there so we can see if it's printing out the right stuff. How do you guys feel about that? I think that that's probably a really intelligent thing to do. And actually, I'm going to make that the first thing that we do. So I'm just going to copy this loop, and I'm going to say display the whole list so we know what's up, right? And so we know what, so we know that it's right, basically, right? So I'm going to change the text here. I'm just going to say everything in the list for reference, if you want to, right? And can we do that by just removing that every other, right? And just print the value as vi. Will that print everything in the list? What do you guys think? Sure, why not? Yeah, that'll do it. That's one way to do it. We learned a different technique in the book too that I guess we could have used too. That's the for each approach. All right, so I ran it again, and now if you look at the output window, it shows the whole thing. So 4, 2, 8, 5, 1, 9, 9, 7, 5, 7. Every other one is 4, 8, 1, 9, and 5. That's right. You guys with me? Do you see my thinking for doing that? So I added a line. I kind of ramped up the program a little bit because it's generating random numbers. How am I supposed to know what's in each position? This is just for reference. So I think that's a helpful thing to do. All right, the next thing that we need to do is to print every even element. So not every even position, but every one that's actually an even number. All right, so to do that, let's start first with this. First thing I'm going to do is just say what we're doing. Display the even elements. And here, I'll put some lines in here so this moves up a little bit. All right. And then to do that, once again, we're going to do a loop. And this time, we're going to do it like this. Once again, the same thing that we did to do everything, because we want to check everything, right? We got to check everything in that structure. Then we need to check to see, is it even? How do you check to see if something's even in Python? Or in any programming language? You mod by 2, and if the remainder is 0, it's even. Right? So if you divide it by 2 and the remainder is 0, it's even. And then if it does that, then we'll print it out. So we're just using the same print command that we've been using. Whatever is in that position where it's even. And then we'll finish it with a print statement all the way here, just to move us to the next line. All right, once again, let's save it and run it. All right, and let's see if this is right. Here's our list for reference. Did it print only the even numbers? It looks like it worked. All right, next thing that we want to do is display the elements in reverse order. This one's kind of fun, because this allows us to use that negative subscript number that we can't really do in other languages. So I think this is pretty cool. So the first thing that we'll do is let's get a print command in there to say in reverse order. And what didn't they do here? They didn't do the end thing. I wonder why. But I'm putting it in. And then we have to figure out how we're going to say this. So now we're going to go in a range that's flipped. We're going to start with the last position, right, which is what? If we have 10 numbers, the last position index number is 9, right? So what I would say to type the for loop for this one is I'm going to say for I in range, and then start with, well, let's start with the number of integers. Well, that's got to be all caps. If I could only type. Minus 1, that's going to get us to 9, right? And then we're going to go from 9 to what? Till the end of the array, which we can actually say, not 0, we can actually say minus 1 and it'll stop because we have to go 1 beyond where we need to go. We need to go from 9 to 0, but the way this range thing works, we have to go 1 past it, so we have to go to minus 1. And then, how do we want to step through it? We want to step through it backwards, so we're going to go minus 1 each time. So that's the syntax for it right there. A little weird. This is not something you see in other languages, folks. And then once we have that, then we're going to go ahead and add these 2 lines in. So one's going to print each value in reverse order, and the other one's going to give us a blank line. Once again, let's give it a try. So let's see if this worked out. So this is what it generated. These are the even positions. That looks right. These are the even numbered elements. That looks right. And is this the reverse order? Sure seems to be. So it looks like it worked out. Okay, the last thing that we need to do is to display the first and the last element only. You know what? That's actually a piece of cake, right? If you think about it. In fact, here, I'll just type it in. It's print first and last are, well, I guess we can just do a colon. That's probably fine. So how do we print the first value? How about we refer to the first position, which is position 0. That's the first value, right? And then how do we refer to the last value? That one's a little more challenging because you actually have to think about it. First of all, we have to figure out how long the length is. We know how long the length is, so you could just put in value 9, right? And that would work, correct? But if you were planning for the future of like learning how to do this, when you don't know how long the list is, you would actually test the length of values, and it would come back with 10, which is 1 too many, and so we would actually subtract 1 from that. So we would do it like this. Or you could just type 9. If you just type 9, you know, I'm not going to like downgrade you for it. I might make a comment on it, but I think programmatically this is a better approach. But here's a way that works. Let's go ahead and save that, and let's hit the run button and see if that's correct. Is 4 and 0 the first and the last? It sure is. All right, so folks, that actually completes exercise 6.1. All right, let's go ahead and move on to exercise number 2. And once again, I'm going to copy the description over. It says, write a program that reads and numbers and adds them to a list if they aren't already contained in the list. When the list contains 10 numbers, the program displays the contents, then quits. This should be a piece of cake, right? Conceptually. But you're going to see it is a little bit of work to get it to happen. So let's get over here. Let's start by creating a new file. Let's do a save as on it right away. And we're going to call this exercise 6.2. I'm going to take that problem description and just paste it in here at the top. And yes, I'm going to do a little bit of clean up here so it's not scrolling all over the place. That should be fine. And then we actually need to get cracking on this part of it. All right, so I guess what we need to think about is how many numbers are we working with? Write a program that reads numbers and adds them to a list if they aren't already contained in the list. When the list contains 10 numbers, the program displays the contents and quits. Now, once again, we don't have to do this, but I'm going to do the same thing I did last time, which is I'm going to say number of integers and set it equal to 10 because they're kind of giving us this hard limit. And so I'm just doing that. Once again, if I want to play with this program in the future and I want to make it 100 numbers, all I have to do is change that number, and then the whole program scales out. All right. Now we need to also set up the list structure we're going to use. Let's just go ahead and call it values again, and we're just setting it up, getting ready to put stuff in it. Now the process of entering stuff into the structure is repetitive, right? Absolutely. And you know, if you look at what the goal here is, it says adds them to the list if they aren't already contained in the list. So we're going to keep looping until we either reach 10 or, yeah, well, actually, we're going to keep looping until we reach 10, right? Yeah, that's for sure. So I can actually, you know, I'm going to go with a while loop on this, I think. And I'm going to say, while the length of values is less than 10, or I'm going to use my constant here. Functionally says the same thing. And see, here I made a mistake, right? That should be what I'm doing. That's where the parenthesis belongs, not there. So while the length of values is less than 10, then we will do the following. Well, we're going to ask people to enter something. We're going to ask them to enter a number. We don't really have a specification as to whether the number should be an int or a float, do we? So what I'm going to err on the side of caution, and I'm going to set up a variable that's going to hold a float just to be on the safe side. It can still put integers in. That's what I anticipate they'll put in, but who knows? You always get those clever people that try to make it crash. And then I'm just going to prompt them to enter a number like this, and then we're going to store it in x. Then we're going to check x. We're just going to say if x, and this is what I like about Python, the beautiful simplicity of this, is I can say if x is not in values, which means it's going to iterate through on its own the whole structure of values and look for x in every position. And if it's not there, then we will add it. And if you guys remember how to do that, it's pretty simple. We just say values append. And what are we appending? We're appending the number they just typed in. Simple as that. Last thing that we need to do is actually display the values. And maybe up here we can say get the values from the user and add to list if not already there. That's kind of the goal, right? All right, and then to output the values, that's pretty darn simple to do. You can just do this, because you just print out the whole structure of it. So by just saying the numbers are, and I issue print, yeah, print will automatically format them. They'll just put them all out there for us. Does this accomplish the goal of the assignment? It does. And with minutes to spare before the end of class, too, I might add, which is pretty good. All right, so let's go ahead and hit run on this one. And now it's going to prompt me to enter a number. And so I'm going to try to keep track of what I do here. You notice I entered 34 again and 23 again. Now I'm putting in something different. Is this 10 times yet? Now I'm putting in a number I already put in. I got one that's 346. All right, there we go. So I was throwing values at it, right? That some repeated, like 34 repeated, 45 repeated, etc. But then ultimately, it grabbed them all, put them all on the screen. They are all unique. All right, folks, that was exercise 6.2. All right, let's move on to exercise 6.4. This one has a lot of parts to it, and we're going to write this all as one big program. And here's what makes sense to me, and the author's like doing it right off the bat too. He says, write a list of functions. So for each one of the things that you see here, we're going to write a separate named function. And then we'll call all of those functions from the main function in the program. So I'm going to begin by, I guess, creating like the kind of the skeleton of the application first. So let's just create a new one and call it exercise 6.4. All right, let's start there. I'm also going to go ahead and define a main program function, like so, where I'm going to put all of my information. For right now, I'm just going to be silly and just put a print function in here and just say, I don't know, hi, just something, so I know that that's my main. The next thing I'm going to do is I'm at the very bottom, of course, I'm going to call main so that it runs. And then all the other stuff that I'm going to do in this program is going to kind of be in between here. So I'm going to end up defining a whole bunch of functions that match up with each one of the little exercises. And then I'm going to go through here and list all the stuff that I need and call it from the main program body. So I hope you kind of have a little grasp of that. All right. So I'm not going to copy all this stuff over, so I'm going to be bouncing back and forth. And then I think what I'll do is I'll maybe grab each one of these and make them a comment above the methods that go with it. And it says, write a list of functions to carry out the following tasks for a list of integers. For each function, provide a test program. All right, so let's go ahead and do that. So the first thing that we need to do is swap the first and last elements in the list. So I'm just going to copy that and come back over to Spider. So I'm going to do a little thing here. I'm just say user defined, not user, we'll just say defined functions. I'm kind of just creating a little area of the program for it. And the first one, well, let's put in a comment here. So the goal of the first one is swap the first and the last elements in the list. And so let's, I don't know, call it maybe swap first last. Seems pretty logical to me. So we'll give it a name and a way to pass data to it. And in fact, well, let's talk about that because, it says for a list of integers. Maybe we should pre-create a list of integers, is my thinking. So why don't we come up here to the top, outside the main program body. So this will be actually what we call a global variable. And we're going to define a set of values in a list, and we'll do that as a constant. And so the thinking here is, let's just get the numbers 1 through 10 in there, and then every time we want to call them in, we'll just call 1_10, and that whole list will come in, and it'll be available to everything inside the program. All right. Now, the other thing is every time we run this, we're going to be passing something in. So we do want to pass something over. And what I'm thinking would be more logical is instead of actually passing the list itself. Now you got to remember that when you use a list, you're calling it by reference and you're not actually calling the values. So what we'll actually do is take the original set of data, if we're going to be moving things around, see my thinking? And we're going to use the list function to make a copy of it and then send that copy to the function for processing. That's the thinking. So let me give you an example of what I mean. So up in the main program body, when I want this actually to happen, what I'll do is I'll create a variable called data, for example. And then I'll run the list function that will take the list. And that command there, what it basically does is it copies the list above and makes a separate instance in memory. So now this variable called data holds that list, but it's not the original list. So I can always pull the original one in, make a copy of it, and then do my work. So once I've pulled it in, then I'll want to go ahead and do the swap, and then I'll call that method that I just created, which is swap first last. And what am I sending to it? I'm sending that list. And then after that, of course, I will go ahead and print, and I'll say, I don't know, after swapping first and last, show the data. So we'll see what it looks like. My other thought is, up here at the top, maybe we should start by actually printing, here is the original list. I think that's really a good habit to be in too, just so we can see it. Not something the author is doing in their solution, but something that I think is just smart practice. All right. And what I might do here is, maybe this description actually sits better up here. Okay, describing it like this. Now, let's figure out the mechanics of actually swapping it in the list. So first we have to figure out how many things are in that list before we can move them, right? So swapping the first and the last thing, if you guys remember, one problem with swapping stuff is when you move one thing to another place, it overwrites the original, but we still need the original to put it back where the other one came from. So we're going to end up with a temporary variable. But here's kind of another little catch, is what if that list happens to be empty? Now, I'm just going to tell you from practicality, we're hard coding the list ourselves. But let's say that we were getting it from a user, like they were entering the numbers. We would want to check to see, is there anything in this thing? If there's nothing in it, there's no point, let's just get the heck out, right? We would just pop right out and we wouldn't do a thing, all right? So all of the little functions we're going to write are going to contain that. The next thing that we're going to do see, this one likes me to do that too. All right, so see, I got a little error there. So I can't print out the data unless I have the data to begin with. That's what that error was. All right, so let's come back down here now and do the actual swapping. That's pretty easy, and in fact, they kind of gave us the code on that in the chapter, but this is basically the technique here. So the technique is take the first item that's in data 0, move it to the temporary spot, take the last item, and instead of just going to position 9, which we know what it is, we're going to go to the length minus 1, which is the same. But that's programmatically a better way to do it, folks. And then we're going to take, so last position, put it in the first, and then we're going to take the temporary one and put it in the last position. So that should accomplish that. let's go ahead and as we were doing before, let's go ahead and just run this and see if this part works. So we're going to do it one at a time. So we got a little bit of a type error here, and I'm just trying to figure out what the problem is. So let's see. That's a whole lot of errors. All right, and it has to be referring to this here. Oh, okay, so what it's saying right here is, it says undefined name data, and the reason for that is here, I'm throwing data at the function, but I never put it here, so it could be received. See, that right there took care of it. Save that and then run it. All right, so here's the original list. Here's after swapping the first and the last. So all the other numbers are the same, but the first and the last one are switched. All right. The next thing that we need to do is shift all elements by 1 to the right and move the last element into the first position. So take that one, put it at the front, and then everything moves over. All right, so I'm just going to copy this part of it for reference. And let's put that description here. Needs 2 comments to make it happen. Same thing that we did here is we'll first make a copy of the data. We're going to do that each time. And then we got to think of a clever name to call this. I think shift right sounds good to me. So I'm just going to pre-type that here. And then I know I have to send data to it. And then we'll send a little message back. And you know, I'm not really sure what like the most efficient message might be. Maybe it's this one here that I'm copying from my solution. Maybe this message is fine. But then we have to go ahead and we need to create this method. So let's come down here and do that. So we're going to say def, and we called it what? Shift right. Shift right. We're going to send data to it. Got a colon there. Once again, we want to make sure that it doesn't error out, so we're going to put this in here. So if it's got a length of 0, we're just jumping out. Otherwise, we're going to continue with our logic. So now we have to do a little bit of thinking. It would be easy to take whatever's in the last position and put it into, maybe let's throw it into a variable called last. And that would be achieved by doing this. So we look at the last, look at the length, subtract 1, that'll be the last position. So we're taking that value and putting it into that temporary variable. Then we need to go one by one and move everything over. So the way that we're going to do that is by using this code. We're going to set up a loop to do it. And first we're going to start with this logic here. A few too many lines in there. All right. If I'm working in that range, once again, I'm going to be looking at shifting things right. And then if for doing that, I want to look at the whole length of the thing, because what's going to happen is we're going to take whatever's in the last position, right? That we can overwrite, because we took whatever was in the last position and we already put it in a temporary holding spot. So now it's okay to take whatever's in the second last position and move it over into that position, because we're free to overwrite it now. I don't know if that makes sense to you or not. And then we're going to do that for everything in there. So we're going to do that in a range. So we're going to go from the last position minus 1 to the first position, and everything's going to shift by 1. So that's why we do a minus 1 there. And then all we're simply going to do is take that data that's in that current spot that we're looking at in the loop, and then take the one that was in the position before it, the -1, and put it in there. And then finally, we'll take the variable that we created and feed it into the first position and fix it. So I already have the output mechanism in place for this. We can actually go ahead and test this. So let's go ahead and save and run. All right. So did we take the last one and move it to the first spot and then everything shifted over? Yep, we sure did. That's the solution for that one. All right. Next thing that we have to do is continue this pattern that we have, but with the next issue. Replace all even elements with 0. That's our task. So coming up here in the main program body, I'm going to add that directive. Once again, I'm going to make another copy of the data, fresh copy, and let's see, what should we call this one? How about replace even? Sounds good to me. Replace even, and we're going to throw data at it, and then we're going to have an output statement, which I already have pre-configured here, that will read this. All right, so now we need to go and create this. So I'm just going to copy that, come down here, and we're going to do a new definition. So we're going to define a new function called replace data, or replace even, excuse me. We're going to begin by checking to make sure that it's not an empty structure. It's just good practice. And then we need to do the actual maneuver here. So now we got to think about how we're going to do this. So if we are going to just replace the even elements with 0, first we have to find them all, right? So how do we do that? You guys remember what the logic is? Mod by 2 with no remainder is how you figure out the even ones. But in order to do that, we probably want to use a for loop, I'm thinking. So let's start with a for loop. I'm going to say I in range, and we're going to go from the first position to whatever the length of the structure is. From there, we'll just do an if statement that does the math. So say whatever data we're looking at currently, mod by 2, if it's equal to 0, that's even. And if that's the scenario, then we're going to replace it with 0. Now, I'm thinking about, like, adding this little tidbit in. Yeah, that's probably a good idea, but you know what, folks? We kind of don't need it, frankly. And the why is that? Because we already have a predefined structure. So now I'm feeling kind of silly that I put it in. I'm going to go ahead and remove it from all of these, and maybe it'd be wiser to cut it, because what if we do need it? So I'm going to save this and give it a run. All right. Original list, swapping first and last, after shifting right, that one we already confirmed, replacing the even elements, so 2, 4, 6, 8, and 10, with a 0. That worked. And now I'm having this little revelation here. Up top here, when I wanted to print the original list, I didn't have to do this, did I? Why? Sometimes I think about how clever I am after the fact. Here's an example, because we could have just done that, right? All right. Let's move on to the next one. The next one says, replace each element except the first and last by the larger of its two neighbors. Ooh, that's a little more complicated. Let's try that, though. So let's come up here and paste that direction in here. All right. Once again, we'll make a copy of the data. And then we need a clever name for it. How about replace neighbors? And send the data to it. And then we will want an output statement. Maybe that looks like this. And then I'm just going to copy this to define my method. So we're going to do a definition, replace neighbors, our colon, and now we have to think about how this is going to happen. So first, let's start by doing this. Let's think about the problem a little bit first. So it says replace each element except the first and last by the larger of its two neighbors. So 1 and 10 are going to stay where they are, but anything else is going to be replaced by the larger of its two neighbors. So for the number 2, the 2 will be replaced by the 3. Excuse me. Right? If I was to look at 6, I'll be replaced by the 7. You notice what the pattern is, though. The larger number is always going to seem to be on the right side, but is that going to be the case after we switch things? You know, so this is kind of like a little puzzle, actually. So what I'm going to do is this. I'm going to start by making another copy of the data. Okay, so let's do that. And the reason I'm doing that is that gives me the flexibility then to do the comparisons without losing the integrity of the original list. Seems a little redundant, but trust me, it's a good practice. All right. Once again, I'm going to iterate through this with a for loop. And this time I'm going to go I in range. And I'm going to start with not position 0, position 1, because we're leaving position 0 alone, remember? And then we will go up until the length, right, which would give us 10, which would stop at 9, but that's 1 too many, so we're going to subtract 1. So we're going to say length of data minus 1, or you could just type 9 in. Then we're going to go ahead and do a little bit of moving stuff around. So the way that we're going to do this is whatever position we're working in, which is signified by this, we're going to check and see really carefully by using the max function. We're not going to do direct comparisons. We're just going to use the built-in function. And what are we checking? Whatever is in data is in position, in position I minus 1, and then comparing it to the data in position I plus 1. So that's just allowing us to check on either side of where we are currently, right? One position back or one position forward. It picks the largest value, and then it stores that into the current position. Believe it or not, that's all it takes to make that happen. Now, this one's flagging here. It says, local variable old values is assigned but never used. Oh, yeah, very true. I wonder why. Why do we do that? I'm not sure why. Now that I'm thinking about it, I'm like, do I need to do that at all? You know what? I'm guessing I don't. Let's get rid of that. I mean, if we're not using it, what's the point, right? All right, and then we already have a display mechanism for it. Let's go ahead and run this and see what happens. Oh, wow, so this one takes a little bit of thinking. So 2 is replaced by 3. 3 is replaced by 4. Okay, that seems to make sense. Everything just really everything shifted left, really, right? The larger number is always going to be on the left. Yeah, that's That seems pretty appropriate to me. And now I'm going back to this old values thing that I just deleted. Yeah, I think it's fine the way we did it, honestly. All right. Next thing that we need to do is remove the middle element if the list length is odd, or the middle two elements if the length is even. Okay, well, you know what? All right, we have to think about this because we might actually have to start adjusting our list in order to test that. So let's get those instructions typed in first. Just follow the same little pattern that we've been doing. And we are going to copy the information. But here what we're going to have to do is I think we might have to create a second list. Let's do that. Let's create a second list. And let's just call this one 1 through 9. And do this with it. That way we have one that's, got 10 and one that's got 9 in it. And so when we test this one, we're going to test it with both. And I hope you guys are following my logic on this. Because it's asking us to test two different scenarios. How can we possibly do that if we don't do it twice? So I think that maybe, well, this one is to remove the middle element. So let's call it remove middle. And then first we'll do it with data 1. And then we'll do it with data 2. And then if we're doing that, then we're probably going to have to do the output twice, correct? So we'll do this. And here's where we have to be a little careful, right? So I have this generic statement here. So we'll put in data 1 and data 2. And I'm just going to put that number in there, right? So we have like a point of reference. All right, but now we actually need to write remove middle. So let's grab this. Let's go down here, define a new function. There's our colon. And here, now this is where we have to be careful. I'm going to use the generic name data here. Because both of the functions are going to send to this independently, and then inside here we'll just use the name data, so it'll be used twice. All right. Now this is really kind of a bizarre thing, because I want you to think about what they're asking us to do. It says remove the middle element if the list length is odd, or the middle two elements if the list length is even. Now, do you remember how to remove elements and then not destroy the structure of the array? You use that pop method, or the pop function. So we can very simply write an if statement in here that I think will cover it. An if else actually should cover it. So I'm thinking if the length of data mod 2 is equal to 1, which means it's odd, right? So if it's odd 1, we remove the middle value. So we'll do data.pop, and then, how do we find the middle value? Well, we would divide by 2. So let's say we had 9 elements, we divide by 2. What's 9 divided by 2? Well, it's 4.5. That doesn't work. How do we do that? Remember that integer division where it just gives you just how many times it goes in? You guys remember how to do that? 2 slashes. So really what I need to do is take the length of data, and let's say it returns 9, right? And if I do this and divide by 2, but it does not give me the remainder, it's going to return 4. Position 4, 0, 1, 2, 3, 4 is the 5th position, which is right in the middle of an odd length array. Does that make sense to you guys? That's okay if it doesn't. But it should. I'm hoping it does. And then we're going to put in the else. If that's not the case, then it must be an even number of elements. And in that case, we're going to remove, this is kind of interesting, we'll run the same math, right? So if we had a length of 10, think about this, that means it's dividing in evenly. So divide 10 positions by 2, I would go to position 5. That is one of the middle positions, right? All right, so I got rid of the first one. Now it's down to 9. Hey, you know what? The same math will work again, right? Because we just did it above. That works for 10, and it works for 9. It works for even, it works for odd. So then we just do that same maneuver again, and that should make it happen. Let's save it and give it a try. All right, let's see if it actually works. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We removed 5 and 6. Okay, so I guess we sent the even one in first, right? Yeah, the one that 10 went in first. So yeah, 5 and 6 are gone. And with the one that ended with 9, we just got rid of 5. So it worked. All right? That's kind of a cool one. Might not be one that where you'd figure out the math necessarily on your own right away. All right, let's move on to the next one. Next one says, move all even elements to the front, otherwise preserving the order of the elements. All right, that seems a little tricky. Let's see if we can figure out how we'll do that one. All right, once again, we'll continue our pattern. And again, we're going to go ahead and copy this in. And then we'll need output. All even elements to the front of the list. All right, so let's call this even to front, and here's our output statement for it. So then I'm going to copy this and define it. All right, so with this one, this is a little different mindset on this one too. First, you know, we are going to send that structure over, and then I got to start thinking here, how is it, well, first of all, we know how to identify even elements, right? That's an if statement, whatever position we're in, we mod by 2. If the remainder is 0, we know it's an even position, right? Because if I read that right, it said move all even elements to the front. So is it the even numbers? That's what I'm hearing, right? The even numbers that are inside the structure is what we want to move. So I got to think about how we're going to do this. Because we're going to have even positions in regular positions. This is how my brain is thinking of this. So here's what I'm going to do. I'm going to set up a variable, and I'm going to say even position equals 0. That's where we're going to start. And then we'll have a separate variable that also tracks it. It's called position for 0, and then we'll start a loop. So I'm going to say while the position is less than the length of the structure, then we're going to run this. So we know that it's going to start out and run. Then we'll check for the even. So we'll check the data in the position, current position. We'll mod it by 2, and if it's equal to 0, then we'll do the maneuver. So because we're basically swapping positions here, I do need to put a temporary storage spot. The other thing I'm going to do is I'm going to pop it out. So I'm going to pull it out of the position, pull it out of that position. So we're going to take that data, pop it out, store it. Then we're going to do an insert. So this is a little bit more advanced one. And we're going to insert it where? Into the even position, which is going to start out at 0 in place and put in that position what's in the temporary variable. The even position will then need to be incremented, so we'll have to like add 1 to it so the next time around it goes to the right number, if I can type it. And that's only if it's even. If it's odd, then we're going to back up here, and we don't want it to be inside the if statement, or if it's odd or if it's not, doesn't really matter. We're just iterating through the list. We're just going to keep a counter following our position all the way through the list. So the POS is basically following our stepping through the list, and then even one is only keeping track of the even ones when we need to. I don't know if that makes sense. Hopefully. Believe it or not, that's all the code it takes to do it. Let's see if this will work. Even to front. Let's go ahead and running it. All right, 2, 4, 6, 8, 10, and they are in order. And then 1, 3, 5, 7, 9. Okay, so it seems like it works. Kind of an interesting little solution on that one, I think. All right, let's move on to the part G here. It says return the second largest element in the list. Not the largest, the second largest. All right, that fits on one line. We'll make a copy of the data again. And maybe we can call this one second largest. Send the data to it. And then let's do an output. Well, I want to think about that here for a second. All right, I'm doing a little bit of a thought in my head. Maybe I'm going to change my approach a little bit on this. Because think about this. It says return the second largest element in the list. It doesn't say print out a whole list, right? So why do I even have to make a copy of the data then? See my thinking? In fact, could I do this? Can I send the original data in there? If it's just looking for the second largest value, I don't have to change it and make a copy of it. And if I'm doing that, I can go directly to printing. So I can just say print, and maybe I can just say the second largest value is, add another parenthesis, and I'm done. See my thinking on that? All right, so knowing that, I still have to create this function, so let's go ahead and grab that. Come down here. One thought, though, is, oops, not there, here. One thought is, I don't want to pass the original list to it, though. I can still give it a different name, so I'm going to stick with that naming structure. And you know what's helpful in finding the second largest value is finding the largest value. So I'm actually going to create a variable called largest, and I'm just going to run the max function, and I'm going to pass in the data. So that's going to find the largest value, and that's a good starting point. Now, from a logic standpoint, if you're thinking about this, I'm going to create a variable for second largest, and I'm going to use this little trick here where I'm going to try to, now this doesn't make sense right now to do this, because if I find the smallest one, that's not the second largest, right? But I'm going to use whatever the smallest one is as a basis of comparison for all the other numbers to see if they're larger but still less than the largest number. You see my thinking? But I got to find the smallest number first to be able to do that. So what I'm going to do is this. I'm going to say for value in data. Now, this is an example of it will just iterate through. I'm not doing a range or anything like that. Just thought I'd demonstrate that approach. If whatever value we're looking at currently is larger than the second largest, and that value does not equal the largest, right? Wouldn't make sense to do it if it did. Then let's go ahead and swap those out. So we're going to say second largest equals whatever the current value is. So only if it's the current number we're looking at is bigger than the smallest that we found so far, and it's not equal to the largest. And if we keep doing that, it will find the largest one eventually, and then at the end of this whole thing, we will return the second largest, which is why we're not returning the whole array, just the second largest value. Let's go ahead and run this too. Second largest value is 9. That is correct. So that one worked also. Next one. Return true if the list is currently sorted in increasing order. All right, return true if the list is currently sorted in increasing order, which we know it is, but we can break it and see if it's wrong, okay? So let's go back over to Spider here and get that in here. Return true if the list is currently sorted in increasing order. Now, once again, I don't have to worry about making a copy of the data because I'm not moving anything around. And so what I'm going to do is I'm going to go right to an output statement that calls the function, sending in the original list. So I'm just going to copy that now to create my new function. Let's go ahead and define it. Once again, I'm going to change the name inside of here because I don't really want to send that to the inside. Even conceptually, it's better to just use a neutral name, I think. All right. So how do we check to see if what we're looking at now is bigger than the thing that follows, or is not bigger? We're going to okay, well, let's go here first. Ultimately, we're going to be returning either true or false, okay? So if the list is in increasing order, we're just going to return true when all is said and done. But I need to go through the whole structure. So I'm going to say for I in range 0 to length of data. And I'm going to say -1 because we're only going to go to the last thing there. Then I'm going to go ahead and start checking each one of the values. So whatever data we're looking at now, if it's greater than the one next to it, to the right actually, if you want to think of it that way, so I plus 1, then go ahead and return false, because if the one on the left is greater than the one on the right, they're not in increasing order. And what we'll do is we'll test it by sending in, by maybe altering the value a little bit. So we're going to return false if it's not the case. Right, and then these extra lines here are kind of a moot point. And that actually should do it. And you know, maybe a better way to test it is to do this. Let's create, I don't know, a mess. All right, so numbers that aren't necessarily in order, just for testing purposes. So let's go 3, 4, 7, 1, 2, 4, 1, something like that. Okay, and then so I'm going to test this one then using the original list. Then I'm going to test it with the one I just created, which is mess. All right, let's run it. Oh, something not liked here. Where are my... Oh, aha. See the P? Okay, let's try it again. All right. The list is in increasing order, the 1 through 10, yes. The list is in increasing order, false. All right. And what might be helpful is original 1 to 10, just so we can see it. Messy list. And that way, when you look at the output, it makes more sense, you know. So just match that up, I think, is a good plan. All right, let's move on to the next one. Just 2 more to do. Return true if the list contains 2 adjacent duplicate elements. All right. All right, let's follow the pattern here once again. So I'm going to go to the end of the line here. Drop in a comment. And then I'm going to think about this. Once again, we're returning true. We can go right to a print statement again. We don't have to copy the data or anything like that. And we might do it something like this. All right. And we're going to call it has adjacent duplicate. All right. So let's come down here and start building it. So define, we're just going to send data in. Get our colon in there. Now, once again, I'm thinking to myself, all right, we're probably going to have to test this twice. And you know what? We're checking to see if it's got adjacent elements that are duplicates. So, all right, we have to create another one. So let's call it, I don't know, dupe. I'm running out of thoughts here. So, and let's just put in some values. Five is a duplicate. Otherwise, there's no duplicates. You guys with me? And see now, because I'm making things of different lengths, see where that length function comes into play. So I'm going to run this one twice then again, and then just send the duplicate one in. Just for testing to make sure that it actually works. And let's say ridge, in original, something like that, in dupe. Right, but let's get the logic in here. All right. All right, so once again, we're going to have to iterate through the structure. So we're going to do an I in range, and we're going to go from position 0 to whatever the length is, for sure, -1, so we don't get that last position, because that doesn't matter in this case. And then we're going to just check to see if what we're looking at, okay, keep hitting those curly brackets until it's an old habit. If that is equal to the one next to it. Now, some people might do this thought here, well, wouldn't you want to check in both directions, right? No, you don't need to, because as you're moving forward, all you need to do is check the one to the right, because you're starting in position 0. You don't have to check backwards, because once you get to the one where you're checking backwards and it's true, you've already checked it going the other direction, so it's irrelevant. So in this case, if we find some that are adjacent, that are the same, we're going to return true. Otherwise, we will return false. All right, let's try that one out. All right, in the original, it's false. There's no duplicates. In the duplicate one, it's true. So we're good. All right. Last one, folks. That was kind of a long one, but so much to learn here for sure. This one, we're going to say this. Return true if the list contains duplicate elements which need not be adjacent. So, in other words, if the number exists more than once, and I think I have a mess will work, duplicate will work, and then we can try one of the original ones too. All right, so we'll go right to a print statement again, because we're once again just returning true. We don't need to show the output. So the way we'll do that is with a statement like this. So we can put the original one in there to start with, and then let's try it with the two others. So we can do a mess and dupe. So this should be false, true, true, right? But let's write the code now. Let's create that function. Once again, we'll replace contents there. And now we need to do the logic. So this is going to take a little bit of additional thinking here, because in order to check any value, think about this, against all the other values in the list, every time you look at one of the values, then you have to loop through all the values to check. See the thinking? So this is going to require a loop inside of a loop. And so let's start by doing this. We'll start with the outer loop. It's going to run through the whole structure. And then every time we run through that, for each iteration, we're going to run through the whole structure again. So there's a second loop, different variables. But notice I got a little difference here. Now we're feeding in the position relative to where the outer loop is. So we're starting in position 0 there, but if you're going to compare position 0, the first one you're going to compare to is the next one over, not the one you're currently on. That's why the +1. And that's why there's no -1 at the end of this, because we're going to be ending before we get there. All right, then the next thing left to do is to actually check and see if it actually is duplicated, so that will just do like this. So we'll check and see if what we're looking at is identical. Just want to get my indenting right here. Otherwise, if they're not, we are just going to return false. All right, that should work if my logic is right. Let's go ahead and hit play on this. And that's what we anticipated, right? This one doesn't have any duplicates, so it has duplicates, false. The other two do have duplicates, even though they are not adjacent to each other. In this case, this has duplicates that are not adjacent, so we know that it is working. All right, folks, what I'm going to do next is, for those of you that are watching the video to get the code, I'm going to kind of give you a screen at a time here. So the first, this is the first part of the code. Second part of the code. Third part of the code. And then finally, the last bit of code. All right, that completes all the exercises for Chapter 6. Thank you for those that stuck around the whole extra hour to finish this. This is a pretty big exercise, but I'm probably glad, thinking you're probably glad you did, because you see how it's done and why it makes sense. And then this video will be out on YouTube fairly soon. So we'll see you guys next time around. Take care.